Hello everyone, welcome to Rational Exponents. In this video we're going to look at fractional exponents and see how to write them in radical notation and then simplify. So rational exponents or fractional exponents would be similar to this, x to the power of m over n. Now that can be written back in as a radical expression or radical notation by using your denominator of that exponent as the root, and then the numerator stays the exponent of the whole thing, the power. Therefore, x raised to the mnth power is equal to the nth root of x, all raised to the power of m. So that's how you would rewrite a fractional exponent back in radical notation. Then from there, we would simplify the radical, the root, and then we would raise it to whatever power that we have to simplify. Okay, so if I have 49 raised to the 1/2 power, the 2 in my denominator represents my root, so the square root of 49 raised to the power of 1 is how I would rewrite that in radical notation. Now remember, a lot of the 2 and the 1 is really understood. So to rewrite that in radical notation, I would simply have the square root of 49. And the square root of 49 is 7. Okay, what about the 1/16 raised to the 1/4? Again, to rewrite that in radical notation, your denominator is your root. So the 4th root of 1/16 raised to the power of 1. So the 4th root of 1 is simply 1. What about the 4th root of 16? What number do I multiply times itself 4 times to get 16? Remember, we can use prime factorization or factor tree or upside down division to get that. And we're looking for groups of 4 of a kind for prime numbers. Now I see that I have 4 2's. That tells me that the 4th root of 16 is simply 2. And then 1/2 to the first power is simply 1/2. Okay, what about -27 raised to the power of 1/3? Well, again, to write that in radical notation, the 3 is your root, the 1 is your exponent. Now, can we take the odd root of a negative number and get a real number answer? Yes, we can. Cube root of -27, we're trying to find a number that we can multiply times itself 3 times. That would give us -27. -3 times -3 times -3 is -27. So the cube root of -27 is simply -3. And -3 to the first power is still -3. Okay, what about -16 raised to the 1/4 power? Now this time the negative is not in the parentheses or not in parentheses with the 16. Therefore, that really means -1 or negative the 4th root of 16. That negative would stay outside of the whole thing, raised to the first power. So since the negative was not in the parentheses, it will not go under the radical with the 16. Now the 4th root of 16, we just found that with the other problem. The 4th root of 16 is 2. 2 to the first power is 2. However, we have this negative outside of there, so my final answer would be -2. Okay, let's look at a couple of more examples. or 3 more examples. 16 raised to the power of 3/4. Okay, so let's rewrite this in radical notation. That's the same thing as the 4th root of 16. Your denominator is your root, and then the numerator stays as your exponent, raised to the 3rd power. Now the 4th root of 16, we just found that. The 4th root of 16 is 2. And then 2 to the 3rd power, 2 times 2 times 2 is 8. What about this one down here? Rewrite it, negative 16 in the parentheses. Notice the parentheses, raised to the 3/4 power. So this time, the negative will go under the radical with the 16. So we want the 4th root of negative 16, all raised to the 3rd power. Now again, we have to ask ourselves that question. Can we take the even root of a negative number and get a real number answer? And the answer to that is no. There is no real number that I can multiply times itself 4 times that will give me a negative result. So since I cannot take the 4th root of negative 16, the answer is no solution. No real numbers. Now you'll find out later that you can use what we call complex or imaginary numbers to simplify a problem like that one, but no real numbers. Won't get a real number answer. Okay, negative 64 raised to the power of 2/3. Let's rewrite that as a radical expression. The cube root of negative 64 raised to the power of 2. Finding the cube root of 64. Again, you can use a factor tree or upside down division to do your prime factorization if you need to. Now, it is helpful to know a few perfect cubes and a few perfect squares when you work these problems out. It could make your work a little easier, a little quicker. We're looking for 3 of a kind since we have the cube root. So I have one group of 3 of a kind for 2's there. Then I have another group of 2's. So the cube root of negative 64 is going to be negative 4. And then negative 4 squared, since that's in the parentheses, that means negative 4 times negative 4, which is positive 16. Okay, hope you found that video to be helpful. Hope you found the video to be helpful. Thank you.